We calculated the self-induction of a toroidal coil, and we did it using our definition of self-induction as flux over current. Now we want to use another approach, which is the energy stored, the magnetic energy stored in the coil, times 2 over the current squared is the self-induction. And the magnetic energy stored is going to be the integral of the magnetic energy density, which we called, I have to be careful here because we have these mu's and u's. This is U magnetic times dV. And our U magnetic was equal to 1 over 2 mu naught times B squared. So now let's figure out how to calculate this integral. Now, the tricky thing, like a long time ago with charge enclosed, is what is the right way to think about calculating the volume integral U magnetic equals 1 over 2 mu naught times B squared, which is mu naught n I 2 pi r quantity squared d volume integrated over the volume. Well, I look at this and I look at the magnetic field. The magnetic field has this radial symmetry. It's a tangential field. And so the volume element that I'm going to use is the following thing. I'm going to use a shell. So this is just a cross-section of the shell. The shell will be radius r prime. It will have a thickness dr prime. So this is a shell that's fitting inside the toroidal coil. And the volume element of that shell is the circumference, 2 pi r prime. The width, that would be the area of a ring of radius r prime and thickness dr prime. And then I have to multiply it by height h. And so what I've been able to do by using this volume element, I'm going to calculate how much energy is stored in that volume. And that's what this integrand represents. And then it's now just a one-dimensional integral. So we'll put all those pieces in. So UB is the integral as I integrate my shells out from r prime equals a to r prime equals b. Now here, let's just clean this up a little. We get a half on the outside. We get a mu naught. Upstairs, we get an n squared. Upstairs, we get an I squared upstairs. There's an R prime squared downstairs. There's a 2 pi squared downstairs. And upstairs, 2 pi R prime H dr prime. Now, once again, there's a lot of constants here. 1 factor of 2 pi cancels. And I get 1/2 times 2 pi times n squared, I squared, mu naught. And we have an h. Now notice it's an r prime over r prime squared. So this integral is just going to be a dr prime over r prime. And that integral from a to b is the natural log of b over a. And now I'm in position to calculate the self-induction. So we'll write it up here. The self-induction is 2 times the energy stored over I squared. And so when we multiply this by a 2 and divide by I squared, I get n squared mu naught h natural log of b over a divided by 2 pi. And that should agree with our previous calculation.